Today we're going to continue solving equations. However, we're going to be looking at special cases. You'll see what that means in just a moment. Remember when we were solving our equations in the past, we always followed a three-step thought process. The first thing we always did is to distribute. Our second step is to always combine any like terms. Remember, when we combine like terms, we focus on each side of the equal sign. We can combine like terms using the same signs. But once we go across the equal signs, we then have to use opposite signs. Remember, opposite sides, opposite signs. And then our final step is to undo our order of operations to finally get our variable all by itself. So what does it mean to be a special case? Special cases often happen when all of the variables end up canceling out. We discovered this happens only in the final step when we start undoing our order of operations and we move things from left to right. Because we always combine or do our distributing first, which happens on the same side of the equal sign. We combine like terms on the same side of the equal sign, and then we finally undo our order of operations. So once this starts, that's when we discover whether our variables cancel out. Now, the type of answers we get will either be no solution or infinitely many solutions, depending upon what we get with the resulting numbers that are left over. So here are two examples that we're going to be focusing on. So let's go through that three-step thought process. The first thing that we're going to do is distribute. So I'm going to first distribute through with this -3 here. And please make sure you're paying attention to signs. So -3 times 5, positive times a negative is a negative, so we get -15. Then -3 times a positive x is a -3x. So now we're on the other side of the equal sign. We don't have any parentheses here, so we're just going to bring it down. We're just going to rewrite -21 minus 3x. Okay, now from here, we would look to see if we can combine like terms, but keeping in mind that we want to look at opposite sides of our equal sign. So over on the left-hand side here, we don't have any like terms, and on the right-hand side, we don't have any like terms. So now we're going to start doing the undo process of order of operations. Now, what I like to do is always move the variables, and it doesn't matter which side you decide to move the variables to. So I can say, all right, well, I'm going to add 3x and move my variables over to the left-hand side. So I can do plus 3x on the right and plus 3x on the left. Now I want to notice what happens here, since they're both -3x and we're adding 3x. In both cases, they're opposite signs, so they're going to cancel out. So what we're left with is just the -15 on the left-hand side and our -21 on the right-hand side. Now what you want to decide is whether this is true or false. Does -15 equals -21? And hopefully you decided that this was going to be a false statement. These two numbers are not equal to each other. When this happens, our solution is no solution. So what does that mean? That means that there is no possible value that I can substitute in for x, and it would have two equal numbers on the left side and the right side. So there's no numbers that's going to make that true. So let's see what happens on the second example here on the right. So once again, we follow the process. The first thing we want to do is distribute. So I'm going to take the 5 and distribute it through the 4 and the negative k there. 5 times 4 is 20. 5 times -k, again, making sure you're paying attention to signs, we get a -5k. And on the other side here, we get 20 minus 5k, since there's no distributing. So now we look for combining like terms. We don't have anything on opposite sides, so now we're going to start undoing the order of operations. Remember, we always start by adding and subtracting, and in general, it's good to always start by moving the variables, because then you can determine right away if we're going to have a solution or not. So once again, it doesn't matter. Let's say I decide to add the 5k to this side first. Well, if I'm adding 5k on the left, then I have to add 5k on the right. And once again, you should notice that in both cases, they cancel out. But let's see what we have left over this time. In this one, on the left-hand side, we have a 20, and on the right-hand side, we have a 20. So then you got to determine if this is true or false, and in this case, we actually have ourselves a true statement. What this means is either infinite, or you could say all solutions. So those are the two different ways that you can answer these types of problems here. And it doesn't matter which one you want to write down. So what this means is I can put any number I want to choose, 1, 20, 1.5, into the values of k, and I would get an answer of a number equaling a number that is the exact same number. So from here, key things to remember is special cases only happen when our variables cancel out. What that means is that there are no variables whatsoever in our problem. And that's when you either say no solution or infinitely or all solutions, depending on whether you have a true or false answer. Now, some of you might see that you will get a variable and say it says equals 0. That is a solution. 0 is an actual number. That's a solution. If you have a variable, there is one solution as long as we have ourselves an equal sign. Okay? If you have any questions, make sure you bring them to class tomorrow, and please do not forget to take the survey that follows. Have a great day.